Hello SGD, Sacred Geometry Decoded. The playlist to this full series will be in the description, and also put a link to the previous episode because I'm just going to be following straight on. So the idea of natural time based on sun, earth, moon and stars, such as the various forms of the month, the lunar year, the solar year or the great year, but how they again connect to geometrical constants built into ancient architecture, ancient units of measurement, how they blend wonderfully together and cross and fold into one another and bring us to these wonderful constants and this very deep knowledge which would link, arithmetic, music, astronomy and geometry together as in the quadrivium. So back to the double vesica. Now I've set it at will be 1 meter. The connection between the cubit itself and 1 meter, and how that links not just the Great Pyramid but all the great pyramids of Egypt, and the same geometry, whether it's Fibonacci numbers, Lucas numbers, how they all blend wonderfully to one another. It's measurable, tangible in this aspect, and it's essentially it's a coherent system. To say it's coincidence, I really given if you look at one point, you can say coincidence. If you look at the whole body and connect them and the metrology and it's essentially universal geometric mathematical constants link them, and so it's really stretching it to say that it's not a design. But so the Great Pyramid itself, at 280 Egyptian royal cubits high and 440 Egyptian royal cubits at the base, we have a 7 to 11 proportion. Now again, as I mentioned in earlier episodes, that 7 to 11 proportion, the Great Pyramid is not a perfect square at the base, but what happens if you include the slight variations, the very good approximates become 99.999% accurate. But this inherent 7 to 11 proportion is the same as this capstone which was found next to the Red Pyramid. Now, neither the Red nor the Bent Pyramid have an angle that matches this. This capstone was not a capstone for there. I would suggest it is just like the Salamis stone and these other ancient artifacts, that it embeds units of measurement, so that, for instance, the masons could come along and set their tools to them. Now, for instance, this capstone was 1 meter high and therefore pi over 2 meters wide, which is 3 Egyptian royal cubits, ERC, Egyptian royal cubits, which is pi over 6 meters. So we already have a connection 1 meter high. Okay, we've already defined this particular capstone. Now it's 3 Egyptian royal cubits wide. Now each circle here, because this geometry is now divided that nicely into thirds, so an equilateral triangle would be built there, but each one of that third is pi over 6 meters, or 1 Egyptian royal cubit, and since it is half a meter in diameter, therefore it is pi over 2 meters in circumference. Therefore the circumference of this circle is 3 Egyptian royal cubits, and so in this geometry, it's not just one arbitrary point, because the meter relates to the second, 86,400 seconds per day, the size of the Earth in relation to the Great Pyramid. We'll show that shortly, but with this geometry, as I showed earlier, which links to Osiron, so many other places, timekeeping, Thoth, Sheshet, all these guides of knowledge, science, or guides of weights and measure, and there we have. Now we've drawn that, and essentially with that we get the proportions to draw the Great Pyramid as well. This is how it looks now. It was basically vandalized. What was the need for these beveled edges at the bottom? What for? I would say, yeah, okay, I'll leave that to the side. But now, for instance, I've shown it in videos before, but if you make a pendulum that's 1 meter long, and the 1 meter long from the center of gravity. So if you use a reasonably heavy weight and a fishing line or a cotton, it's essentially 1 meter to the center of the gravity of the bob. Now at 30 degrees, if you swing that within 30 degrees, you will get 1 second. It will, and even as it gets down to its lowest, as it's just at the very last moment, it will still keep time to 1 second. Prior to quartz crystals and later developments, the pendulum was the best way to measure time. And now that 30-degree angle in itself is not arbitrary as well. So it's not just I've just chosen 30 degrees. Riccioli and other people who have studied this have said that it needs to be at a shallow angle. That's why grandfather clocks have this shallow angle. If you go above 30 degrees, you start to affect the time because the pendulum will start to fall essentially. So you need to keep the string taut. Now in a grandfather clock, they have a solid bar to the weight at the end, so they overcome that problem. But if you're using a pendulum on a string, you have to keep it at a shallow angle because otherwise the string bends at the high point. A bit like when you're on a swing. If you get really high on a swing, you don't swing neatly. As you get to really high, you sort of drop and then it catches you again. So that's the 30-degree angle is not an arbitrary angle. And it just so happens that a 1 meter pendulum at 30 degrees is pi over 6 meters, which is 1 Egyptian royal cubit. So 1 second equals 1 Egyptian royal cubit equals pi over 6 meters. Now radian is another way of measuring the circle, so 360 degrees. Radian is pi over 2 radian to measure the circle, and then again, pi over 6 radian. It's another lovely connection, and it just so happens that the Great Pyramid is just short of 30 degrees north of the equator, just short of it, and it's actually 10 times the base of a pyramid is the distance from that, and there it is times 10, times 100, times 1,000. I'll get into this again later because it links so many other aspects, times 10, times 100, times 1,000. But for the moment, 1 meter pendulum would be a 1 second pendulum, depending on your location on the Earth. The further you move away from the equator, it changes the length of the pendulum. So at 45 degrees north, it would be 94.5 centimeters. But again, as you move from north or south of the equator, it changes. But a 1 meter pendulum is above 99.99% accurate to keep time. So the Egyptian royal cubit, so a circle of 1 meter gives you 6 Egyptian royal cubits the circumference. Now that same geometry, which brings us to the seed of life, is the same geometry which is in the double vesica, and it's the same geometry that gives us this 24. So you see there are 24 points to this circle. That's exactly the same. So if you keep subdividing the hexagon, the Star of David, or the seed of life, you get 6 points and 12 and 24. And that 24-pointed star, to get 30 degrees, gives you a Templar cross. We'll come back to that, but some nice quotes there. And God of astronomy, geometry, architecture, weights and measures. So sticking with this, the 1 meter pendulum, creating that arc of an Egyptian royal cubit. Now we have Euler's identity, which is considered one of the most beautiful equations around there. And that's, again, the beauty of this maths, especially this +1. And I'm going to do a video just on +1, -1, and how so much of this is connected to this just really beautiful, simple math leads to this very complicated mathematics, geometric constants. But Euler's number, that's essentially 1 plus 1 factorial plus 2 factorial plus 3. So if you ever see 2 with an exclamation point at the end in an equation, that means 1 times 2. 3 with an exclamation point at the end means 1 times 2 times 3. This is one of the transcendental numbers. But so now if you just highlight this part, so essentially it's Euler's number minus 1. And so there's a bit of a cheat really there in Euler's number because it's 1 plus 1 and then this series. But if you just focus on that part, you get E minus 1. And 1 Egyptian royal cubit almost precisely equals E minus 1 feet. So pi over 6 meters equals 1.7178, etc., feet. E minus 1 is 1.71828. And that difference, okay, now E minus 1 is also is one of the proportions that comes from the Great Pyramid or the capstone at the Red Pyramid, that 7:11 proportion, and that's built in there. Now using idealized measures, you get 1.71713, which is 99.933%. I'm not showing it here, but if the pyramid has slight variations in each side, if you include those slight variations, you get 99.99 and above percent to E minus 1. Again, I'll be linking CPAK Alan Green trailer. Here is a screenshot from there, and how these same inherent proportions of the pyramid will link the English foot, as it's called, the cube, Royal Egyptian cubit, and the meter together. So the proportions, but also the measurable elements of the pyramid lead us to wonderful connections, which lead us to wonderful geometry and also musical connections. I'll get into that eventually. So E minus 1 is 1.718 ... 1 Egyptian Royal cubit is 1.7178, etc. English feet. That's the difference from those between those two is the human hair. So the number might look slightly different, but it is without very, very sophisticated measuring technology, you're not going to be able to measure that difference. Now back to that capstone, which has the same 7 to 11 proportions as the Great Pyramid, therefore, which incorporates the meter. That's the same geometry. So the pyramid is just an oversized, large version of this. So that same tool is in there. Now, pi over 6 meters is 1 Egyptian Royal cubit. This is also built into the Great Pyramid. I touched on that earlier. Yeah, it's in there again above 99.937%. Now to put that into a perspective, that's based on best survey data. If they were a couple millimeters either way, it would basically hit 99.999%. And also have a relationship of 86,400 seconds per day. So again, this 30-degree angle of a pendulum is not an arbitrary one. That's built into nature. That's necessary. If you go above that, it affects the timing. The geometry of the cubit and the meter linking together via the second, and time 86,400 seconds per day, as in that 1 meter pendulum. Now, if you stand at the corner of a Great Pyramid and you include the sockets, there is these features at the corner. Very important to include those, because what you would see, the maximum visible distance of the base of a Great Pyramid, is the rotational speed of the Earth per second. Now I'm going to show later, because the Mohenjo-Daro foot, if you make a pendulum of 3 Mohenjo-Daro feet, that creates the cubit which describes the base of the Great Pyramid at 4,400 essentially canonical cubits. Yes, we'll get to that eventually, because there's some extraordinary connections between timekeeping measurement and apparently unconnected units of measurement across the ancient world. But so the speed of the Earth, rotational speed of the Earth per second. Therefore, if I multiply that distance by 86,400, as in 86,400 seconds per day, built on a 1 meter pendulum, which incorporates Egyptian Royal cubit, we get the equatorial circumference of the Earth. If I multiply the height of a Great Pyramid and include, actually not the, I should have said socle. Okay, sorry, there it is. The height of a Great Pyramid, including the socle, the paving stones underneath upon which it sits, we get the polar diameter of the Earth. So we have the circumference of the equator and the polar diameter, and it's an oblate spheroid, slightly less at the pole as it is at the equator. Therefore, timekeeping the cubit, the meter, and the second, and the relation and the size of the Great Pyramid itself brings us to this extraordinary geometry. Now, 43,200 is sort of the standard one that people reference. Well, that model describes the Earth like that. The 86,400 model describes the Earth like this, and it also incorporates the cubit, the meter, and the second. So there you go. Now, this is this particular system is just much more elegant, incorporates more information. Okay, I'm just over 14 minutes. I'm going to have to pause, and I'm going to put it in another video, because we'll be looking at 86,400 and these are other numbers built into there and the connections between them. Okay, so cheers, have a good one. Next part will be up very soon.